Thank you very much. It's great to be here at TOKEN2049. Appreciate you guys coming. We're going to talk about compute, which is the missing piece in a Web3 world. And I think we've made huge advancements across this Web3 ecosystem, but we're not there yet. And this is what will take us there. So what is Fluence? Fluence is a peer-to-peer compute protocol, and it enables this decentralized computing, which I'm going to talk about. A little bit, I helped found Hedera Hashgraph, and am a co-founder of Fluence Labs. What is compute, first of all? And this is a little bit high level, most of you may understand this, but it's the processing that underlies all transactions that do not, and all processing that's not on your phone or your desktop. And that kind of is central to any type of complex application. So where is compute? Compute takes place in two places right now, either the cloud or proprietary in-house servers. And importantly, the cloud is not a benign, puffy, white, ethereal organism. It is dark, and it is depicted here as a rain cloud and a storm cloud because it's dangerous. And so don't buy the white, puffy cloud logos that you see from some of the providers. What's wrong with centralized compute? Well, if it's hosted at particular companies, it's clear, there's censorship potential. And we've seen that Facebook, Twitter, very easy for a centralized company to censor. And if it's at the cloud, the issue is dependency. And the cloud is very easy to get an application spun up, but once you're up, it is not an easy place to leave. They own your data, you're subject to the services they offer and the pricing that they give. And that's very hard to leave. And that's why they're growing revenues at 40 to 50% a year. The other problem with centralized compute is deplatforming. And we think of deplatforming in two different ways. First is what applications can do. And applications like Twitter or Facebook can just cut you off for no reason. We see it happen regularly. And that happens with a variety of opinions they don't like. It also happens by the cloud can kill applications. And we saw that happen most publicly with Parler. And no one's life here, I don't think, was dramatically impacted by Parler's deplatforming, but it was a big wake-up call to people and companies on Amazon as to the power they have for any violation of a 58-page term of service that keeps changing and keeps growing. And why does this happen? Governments. Governments are behind deplatforming because as companies grow, they have to interact with governments, and governments have more and more influence. But the other issue with centralized compute is that the systems are closed, and that inhibits innovation. And you used to have Twitter and Facebook that had open APIs and were easy to build on. And in 2018, those APIs were closed off, and that prevented companies that sound somewhat trivial like Farmville or Tweetbot or Twitterrific, but if you expand that out to the world of applications, when you inhibit innovation, you don't even know what you're missing. And it just prevents developers from experimenting and adding on top of it and keeps us in the world that we know today. And it's hard to imagine what else is possible. We think Web3 may solve that, but if you get to Web3, you see the same problems. And a lot of Web3 companies actually rely on the cloud right now. Infura, a critical application, relies on AWS. It's nice to have a decentralized front end, but if your computation happens in the cloud, you can be turned off, again, by a government directive, by a term of service perceived or real violation, and that is not a comfortable place to be. You also have Web3 dApps that are not on the cloud, but instead run their own servers. That's centralized too. They may have the best intentions, but that is not secure, that is not safe, and that is most definitely not decentralized. And by the way, this isn't their fault. It is just the fact there hasn't been an opportunity to change and to have a decentralized compute backend. So is this the internet we signed up for? I don't think that's the case. It was definitely not Tim Berners-Lee's vision, but the internet rewards scale. And every company that starts to grow, it gets more revenue as it gets more customers, and you end up with oligopolies and even monopolies in different areas. And these dominant companies just will have relationships with governments. That's just how the world works, for better or for worse. You name an industry, whether it's legacy media companies, whether it's the railroads, all of them had very deep ties to existing government organizations, and that leads to levels of control that vary. And we're never in a more centralized place than we are now because of the architecture and the incentives and the economics of the web. So how do we get here? We started off with mainframes and desktops, and then kicking and screaming, people moved to the cloud. And to give a sense of this type of transition, I was investing in data centers, which was kind of the early description of the cloud, back in 1998. All right, do you realize how early that was? AWS didn't start for years after that. That was probably 10 to 20 years too early to be looking seriously at data centers. We're now, the next generation of that is peer-to-peer platforms. The cloud is dominant. The British regulator just announced that 81% of cloud revenues in the UK are Amazon, Google, and Microsoft. And there is now an antitrust investigation about those cloud companies. That's how dominant they are. But that took 25, 30 years to get there. This next world is the peer-to-peer world. We're at the very beginning of it. And what is peer-to-peer compute? Peer-to-peer compute is this compute, but happening in a decentralized way without a centralized host. Interestingly, you can run it on a cloud, you can run it in a centralized company, you can run it in a house, but you're in an open platform, people can switch and move their data around easily and seamlessly, and all those entities do is provide the infrastructure. And the open peer-to-peer compute is a protocol that uses that hardware infrastructure and allows compute to happen and move easily. There's two types of compute, and everyone here is very comfortable and knows blockchain compute. That's smart contracts. And smart contracts are peer-to-peer compute, and they work, but they're only sufficient for deterministic compute. They're great and perfect for DeFi, and that will work and continue to work forever. But they're deterministic, redundant, constrained, and expensive and slow. General purpose compute is what 99% of the web runs on, and that's what we need to move Web 2 into Web 3 and have proper decentralization. That is what Fluence is working on. Permissionless with universal runtime that's cheap and fast and infinitely scalable. That's where we think, that's what we have to get to, because scaling blockchain compute to billions of transactions a second, like the web, is not a realistic goal. So why is this the future? Because peer-to-peer is scalable, secure, and resilient. It can scale faster and cheaper when you have a hardware marketplace around the world that can respond to price much faster than any centralized company. So a global marketplace for hardware, for compute, whether it's compute or storage, is infinitely scalable and can respond much faster than any centralized company. Also, it's secure. It's censorship resistant because there is no one host. There is no one company that either hosts or provides that application. And so there's no legal entity to compel, no management to threaten, no directors to influence, and no shareholders to pressure. So open peer-to-peer networks and protocols are the only chance we have to resist the power of governments dominating and controlling kind of every aspect of the web, which is the direction we're heading in. It's also resilient. Peer-to-peer networks don't have single points of failure. And here, we can see and have been well publicized, Amazon outages, Facebook, WhatsApp outages. We've all seen that. And those, I think, we can chalk up to centralized systems and user error and even software errors. But what we haven't talked about are deliberate web outages that we can see in Iran and we see many other places. Peer-to-peer systems are the way to create systems resilient to both inadvertent outages, but also deliberate attacks at infrastructure. And so this is something also critical for the well-functioning kind of world that we want to live in. And peer-to-peer compute platforms right now exist in payments, right? You're not seeing Bitcoin shut down in any of these countries, and you're not seeing, IPFS or Filecoin shut down in these countries. They work, and that's terrific, but we don't have compute. And without compute, you can't have that type of environment that works for actual functioning complex applications. And so look at the traction. We have traction in peer-to-peer payments with Bitcoin, Ethereum, that's not going away. And we have traction in storage. Storage is kind of the great story of peer-to-peer over the last several years, especially with Filecoin just hitting 200 petabytes of storage. That's a huge amount of storage. There is a long way to go, but they are scaling. And so that, I think, problem is well on its way to being solved. But peer-to-peer compute in terms of smart contracts is tiny. And how tiny? Hard to gauge this market. It's a couple $100 million, maybe it's 300, maybe it's 500, you see estimates all over, and it's going to grow quickly, it's going to get to multi-billions. But let's compare that in scale. Cloud revenues are 126 billion in 1 quarter, all right? On a year, that's about 4,000 times more. And cloud encompasses content delivery services, encompasses storages, so it's not just compute. So that's not a fair apples to apples comparison, but it gives you orders of magnitude scale as to what we're talking about here, and shows how tiny smart contracts are in comparison to what we need to do in order to get really functioning systems going. And why is that? It's because it's hard. And why is it hard? You need to be decentralized, verifiable, and scalable. And so without blockchain, that verifiability is a challenge. And so Fluence is using a combination of Web of Trust, Quorum, and ZK proofs to achieve that security. And when you have that, which is the verifiability. And then when you do that, you're not constrained by the blockchain limitations. And the competition isn't blockchain. The competition is AWS and the other cloud providers. And when you get to that world, which is where Fluence is, what do you get? What do you enable? Well, no closed ecosystems. You can have open applications that are easily composable and shareable, and that is lead to terrific innovation because it's a creativity accelerant. You can build easily on top of other applications. You can be sure you're not cut off. You can, when applications and code is hosted, they can be hosted by anybody and can't be turned off as long as there is one single host available. So it's unstoppable. And that's where we want to be, is a very creative, very secure, unstoppable world. And what does that world look like? It looks like the most beautiful transparent cloud on a summer day that you barely even see because the cloud is out there, but it is so light and so thin that you almost don't even see it. That's the type of cloud that is okay, that's not a storm cloud. That's the cloud you want, in which when you marry storage and with compute, and obviously payments are a critical part of that. That is what where we are going, and the vision that I think we all will benefit from achieving. And where does Fluence stand in this? We've launched the peer-to-peer network, so the peer-to-peer computation network is live, it functions. The language Aqua, which allows the native composition of peer-to-peer applications, is live. It abstracts out all the complexity of building peer-to-peer applications, the peer discovery, the failover, that is solved with Aqua, so you can compose applications with just several lines of code. It's a terrific innovation. This year, we're launching the DAO. It's going to be a Swiss foundation. It will govern the Fluence protocol, and that's where we are right now. And then next year, we're adding on the compute economy, and that's sort of like the Filecoin to the IPFS. And that will allow hosts to be paid, and it will allow open source software providers to share in that hosting revenue as the code they write is used, which is what we think will inspire a terrific amount of code to be on this open peer-to-peer world and lead to ever-growing innovation. And so find us at dash.fluence.dev. You can find us at Fluence_project on Telegram. And let's think about what kind of world we want to live in. Do we want 3 companies controlling internet hosting? Do we want nation states censoring all manners of either applications or communications? Peer-to-peer and open source is the only way we have to prevent that world from happening. And so let's think about, our mission here is going back to Tim Berners-Lee about the goal of the web is to serve humanity. We don't even know what might be coming. When Tim created the HTTP protocol, do you think he could have imagined Uber? No chance, right? And so what we're doing is trying to create the platform and the rails that will allow that level of creativity to happen and exist. But we have to have this compute layer in order for that to happen. So with that, find us at fluence.network or Discord Fluence.chat, and we have a booth in the other room. So I appreciate your time. Thanks for coming.